So in Houdini 20, there are a couple of very nice tools for dealing with lidars. We already had before this node here in subs called lidar import, which we could use for importing point cloud lidars in Houdini before. But any operation after that, that had to be kind of done manually, meaning that you would have to create your own setup to deal with lidars. And in one of my videos, I believe it's on YouTube, otherwise it would be on Patreon, I created my own tool for dealing with lidars. And it kind of worked very well, but you needed to do a bunch of things here and there, a bunch of operations and whatnot. And now Houdini comes with tools out of the box that you can use for dealing with lidars. They are still simple, like Houdini is not really like a survey tool, so do not expect to have the same level of control that you would have with specialized lidar tools. But generally speaking, in visual effects, we don't care that much about all the data that potentially could come with a lidar point cloud. That is something that, generally speaking, we deal with using other software. Uh, Generally speaking, software that we usually buy with the lidar scans. So these tools are not meant to replace those other tools. That's my guess. But these tools, I guess they are meant to be used for visual effects artists, just to get something up and running as quick as possible. And that's, I guess, what I want to show you today. So to start with, I'm just going to get a lidar point cloud that I have here. So basically, I'm gonna paste the path here, and this is the lidar. And as you can see, the orientation is a bit weird. It's kind of floating in the air and whatnot. So in the lidar import node, there is this option, if you scroll down, called transform. And here you can click on move centroid to origin. And that, as you can see, has set these coordinates here, meaning that my LiDAR is now in the origin of the scene. Cool. And then we can add any other transformations, right? This is just like regular Houdini transformation. So I'm going to set the rotation to -90. And now I get my LiDAR in the right place. I'm going to switch quickly to the front view. Because this is it is a little bit underground, so I'm basically going to move this one a little bit higher. Oops, here, so it's kind of above the zero level. All right, that should be it for me now here. This lidar is an aerial lidar captured with helicopters, so it's not extremely dense. It has some good information, but yeah, it's not extremely dense. If you are using a terrestrial lidar to capture something like a building, your point cloud would be way denser. This one has only like 5 million points, which is not that bad. But one of the tools that they are shipping with Houdini 20, it is basically something called point cloud reduce that you can use for reducing the amount of points that you have. In this case, I don't think we need to reduce the point cloud here, but anyway, just to show you how this works, this will use this box size, and it will use this sample method from average, close to center, or random. This is something that I had in my tool when I built it, and it was using not really voxels, but it was using kind of like a random points or points that were very close to each other. So it will basically reduce the amount of points in your point cloud. So here, if I set this one, let's say to 1, we can see that now we have 3 million points. If I set it to 2, we are getting bigger box sizes. So now this one is only like 1.2 million. If I set it to 5, and as you can see, I'm getting rid of many points. Now I'm just left with 226,000 points. So I'm gonna go back to the original thing. So yeah, it's 5 million points. So yeah, maybe set it to something like 0.5. So at least we're doing something. So it's 1.3 million. But again, this is not very dense, so I don't think we need to do anything here. But I just wanted to show you that. Then if you click on voxel population, this will create this attribute that basically will display. If you display that attribute, you can see basically what this voxel size is doing. So again, if I set that one to, let's say 2, you can see that, those are the voxels that is creating in order to delete some of those points. What did I use before? 0.5? Yeah, something like that. So I'm gonna get rid of that. And you can also make groups. So if there is a very dense area because there is a lot of vegetation, you might use this point cloud reduce only in that area. It works quite well, and especially if you're using very heavy lidars, that would be a very useful node. Okay. By the way, let me go here because this lidar import can also import colors from the lidar if your lidar comes with that information. So you can set that one to attribute color from point cloud, and then you get the color there. It looks a little bit washed out, so something that you can do is attribute adjust color, connect that one there, and now this is actually replacing the color because the adjustment value set to set. So let's get rid of that. Let's go to color correction, go to gamma, and maybe do something like 0.4 or 0.3. And now we can see all the beautiful colors of this LiDAR scan. Great. And that that attribute, of course, will travel across the pipeline. So, this node is not deleting any attributes or anything. Okay, cool. Then when it comes to meshing, because at the end of the day, these are just points, right? So at some point you want to convert this into geometry. You can use a point cloud surface, and this will mesh your point cloud. But it is important, this node requires normals, and for that they introduce also something called point cloud normal. And if we connect that one here, it will take a few seconds to calculate the normals. There you go. That's it. I think we should be able to visualize that thing. If you don't see it, you might have to go here. And yeah, we have it. Let me go here. Let's add a color. Okay, that's cool. And I want to show the normal. Okay, and now we can see some of those normals. The problem is that, generally speaking, lidars of natural environments, they are really big, right? This is, I believe, like 80 square kilometers, or I don't remember right now, but basically it's very large. So this proximity radius, this will basically calculate normal between points that are close to each other. And because these distances are huge, and you can see the normals there, we need to increase this proximity radius quite a lot. So if I set that one to something like 5, it's calculating again. It will calculate the normals based on bigger groups of points. Okay, That's cool. And also the neighborhoods, right? So also that will also encapsulate the same normal, not only in the points that can find in this radio, but the neighbors as well. So if we make this one larger, it's gonna sample from a bigger radius basically, or more points. Okay. Then there are two different methods here: local propagation and orient normals towards hint. For large lidars, orient normals towards hint should work better. And then another thing that is important is these x, y, z coordinates here. This is a terrain, meaning that normals, generally speaking, they're going to be pointing upwards. So make sure that your x axis here is, sorry, the y axis here is quite large. So if you do something like 10,000 or something, this will help you to kind of calculate those normals based on the direction that you want, which is pointing upwards. This other method might work better with smaller lidar. So if you're doing something like an object or like an interior of a building, this should work better. Okay, cool. So now we have normals. We don't need to display them anymore. So now this point cloud surface should work as expected, right? If you don't have the normals, this one wouldn't work. So what you can do here is basically the amount of subdivisions that you want to use for meshing your geometry. By default is 8. We can go maybe a little bit higher. Then we have this sample target. So this is how many points is going to sample in order to create a 3D geometry out of them. Generally speaking, you want to increase this when your point cloud is very noisy. Mine is not that bad. I mean, you can see that I have bushes and trees. So generally speaking, those type of elements would create noise, but it's not that bad here. But yeah, you have a lot of noise. Just increase this one, and that will help you to reduce the noise. And same with the smoothing iteration. That will also smooth the transition between different points. And finally, you have this boundary type. In my case, it should be open because this is an open space. If you're doing something, imagine that you have a LiDAR of a column, for example, or a pillar, then it should be set to closed. Okay, so let's do that. Let's displace this point cloud surface, which will take a couple of seconds to calculate. Shouldn't be super slow. Of course, it depends on the amount of points that you have in your LiDAR. In our case, should be pretty fast, I hope. Okay, it's working. Okay, this is done. It took like, I don't know, 45 seconds or something. And now we have a point cloud. Sorry, a mesh. I think I'm displaying something here that I don't want to display. Okay, the normals. There you go. So now we have this mesh, this 3D geometry that looks pretty decent, right? Of course, the area of the trees and the bushes is a little bit noisy, but that is expected. Of course, you can use any Houdini operation here to smooth that out, or you can just play with the sample target. But generally speaking, it's working just fine. And as you can see, this point cloud surface is smart in the sense that if it doesn't need that many polygons, it will add less polygons, and in areas where more polygons might be needed, it adds more of those here and there. And of course, after that, this is just a geometry, so you can resample it, you can poly reduce it, you can do whatever you want. The only issue here is that we lost the color attribute, but that's not a big deal. We can just create an attribute transfer, and transfer, we had the color here in the points, right? So let's do something like that, and then we can just transfer we can go from points to primitive and transfer whatever the the color. And let me get rid of the lighting so we can see it a little bit better. And this is basically what we get. Okay. And same thing, we can always add a color attribute adjust, and if we feel like we need to tweak those colors, we can do that. I feel like it's a little bit darker now. There you go. Cool. And this is how everything is working. So we have a decent geometry. And again, if we want to use the colors for texturing or for driving the color of the scatterers or whatever, we can just use this color here. And this is working just fine. And again, this is just a geometry. You can do whatever with it. It's just a geometry. So any Houdini geometry operation will work just fine. But the cool thing is, like, now you can move this into the height fields world, of course. So you can basically just create a height field here, and this height field, it's too small, right? So let's make it a little bit bigger, something like that. All right, so now we have this thing. I'm gonna add a height field transform as well. Make sure that we are below the surface, and I think we are already, actually, aren't we? Yeah, we are already below the surface, so we might not need that one, because now what we can do is just project this terrain that came from a Lidar and bring it into height fields. So if we just do like a height field project here, and we take the terrain, and then we take that geometry, let's project this here. There you go. And now we have a height field that should be matching perfectly, as you can see here, our Lidar. Right? Of course, we get this margin that we got from the point cloud surface, but of course we can get rid of that at any point. So we can basically add a height field crop. There you go. Now we're cropping that, so we just need to make this a little bit bigger, maybe a little bit more. There you go. Now we're getting already that, so maybe not that much. All right, maybe just 2000. There you go. Cool. And now we have this fully functional height field, which has a resolution of 1002 pixels. Cool. And now, because we are in height field world, we can perform any height field operation. And this is, of course, up to you, whatever you're trying to achieve with this, because this is already a realistic terrain. You might not need to do anything to it. But if you wanted to, you can just do something like height field erosion, for example. Or let me get rid of visualization for a second. Or, height field noise or whatever. So if you want to modify this with some extra noise, you can add that. If you want to merge these or combine these with another height field, you can do it here in height field world, which is faster than doing it with geometries or whatever you might need. So I'm just going to enable this erosion. I'm gonna make this a little bit more extreme and simulate a few frames. and this, starts adding some detail to this terrain, which in this case might be too big, but anyway, I just want to illustrate the point here. But most likely, I use this not to add terrain, but to generate extra masks, because of course I can just take these into Nuke or Photoshop or any other software and start extracting, let's say, the paths and create a mask for that, or for the roads and for the different coloration of the terrain or the dirt or the rocks or whatever it might be. But also using this height fill erode, now you would have extra masks here that again you can just export as regular masks with a height fill output, right? And create multi-channel masks or splat masks or whatever you want to call them. And then you would have extra masks for working on your look dev or working on your scattering systems. From here, at the end of the day, you're gonna be converting these to a geometry, right? So once you do that, you end up with a geometry. And again, you can use another attribute transfer here and just transfer this color here, right? So you end up, you have this color here, right? So you end up having the color back into a geometry that you modified. You started with a Lidar import and then you modify that using your height fill tools, and yeah, you get basically your thing here. So yeah, I don't know. I thought these were very nice tools that can get you up to speed very quickly without having to create your own tools. And again, of course, if you create your own tools, you're going to have more options and you can customize that even farther. But I don't know, as a starting point, I think this is very cool. So yeah, this is what I wanted to show you.